So anyways, we're going to put some ice in our water. Water is going to cool down. Ice is going to heat up and do other things. So we'll approach this the same way. Q gain equals negative Q loss. Okay. However, what you cannot do is this, exactly like we did it on Monday. In other words, you cannot just say, all right, the ice is going to go from negative 20 to positive 3. And why is that true? Because it's not going to go from negative 20 to positive 3. It's going to go from negative 20 to 0, and then what's it going to do? It's going to melt, and then what's it going to do? Go from 0 to 3. So it's kind of a 3-step process on the gaining side to get it up to the 3 degrees. Okay? So let's write that out. We'll do it kind of in conceptual form. So the Q on the gaining side, that's going to be ice, right? So first of all, the ice, Q of ice, is going to heat up from negative 20 to 0. So you need some heat to get it up to 0. Then you need some heat to melt it. Then you need some heat to raise it up. And it's now going to be in liquid form. It's no longer in ice form because you melted it. You're going to heat it up from 0 to the final equilibrium, which we said was 3 degrees. So on your gaining side, you have these 3 steps. You're going to heat up the ice, you're going to melt the ice, you're going to heat up the liquid. What about on the losing side?
It's just
Okay, it's just going to be the change in temperature, right? So we're going to change from liquid form from, what do we go, 20 down to 3. Now if I started off as steam or something, then yeah, you'd have to condense it first. But since I started at liquid and it ends at liquid, if there's no change of phase, then you can just do this simple change. Okay, alright, so let's go ahead and do it. So the Q for ice, since it's a change in temperature, you're going to be using your MC delta T. Think of the delta T here. Whenever you change temperature, you use the delta T equation. Whenever you change phase, you use the MH equation. Okay, then when we go from 0 to 3, we're going to change temperature, we'll use the delta T. On this side, we'll go negative again, and it's just changing temperature, so we use MC delta T. Okay, so I'm going to label these. Remember, this is ice, ice, ice. This is mass of the ice again. This is the mass of the ice. Now be careful, this is now in liquid form, so I'm going to put C of the liquid. And then this was the mass of our liquid, C of our liquid, T of our liquid. Okay, let's just plug in some numbers. So our masses, our ice mass was 0.1. Because I was making sure you were paying attention. Okay, HF. So 0.1, C for ice, 2060. Temperature change for ice, negative 20 to 0. So that's going to be a 20 degree change, positive because it's heating up. Mass of ice is still 0.1. Heat of fusion of ice, 334. mass of ice. Now be careful, this step is where a lot of people make some errors. You're still going to have the same mass of the ice, but your C is going to be in liquid form. So this one's going to be 4180 here. So it's no longer solid. Okay, our temperature change, we went from 0 to 3, so we're going to have a 3-degree positive change. Okay, so that's all on the left side. That should equal negative. Now this is the mass that we're looking for. Again, it's in liquid form, so we're going to put 4180. And what's my temperature change? Negative 17. So from 20 to 3, so that's a negative change. And again, notice you're going to take care of that negative here. So negative, negative, it ends up being positive anyways. Alright, go for it. Algebra is actually not that bad here. Just do all the math on the left. And then divide by these. Someone get the answer yet? 5.5?
No, 0.5, sorry.
0.55, is that confirmed?
Yeah.
I got 0.6.
0.55? Good, good, good. Sounds about right, actually. Okay, and that's about, like a normal water bottle. That'd be about the amount that you'd find in a normal water